Note that any set possessing all the above properties of inequality, that is written that all 11 properties is called a field. And from the multiplicative properties of inequality, we conclude that if both the sides of an inequality are multiplied by a positive number, it means if we have a situation where we have both left hand side and right hand side not equal to each other and they are multiplied by a positive number, its direction does not change. But multiplication of the two sides by a negative number reverses means it changes the sign of the numbers, and changes the reverses or changes means the same thing, the direction of the inequality. For example, a and minus a are additive inverses of each other, right? Like positive a is positive a, and if we multiply positive a with minus 1, it becomes minus a. They are additive inverses of each other, since inverse means the opposite of it. Since by definition inverse of negative a is positive a, right? Therefore, negative, if it is multiplied with negative, it will become positive a. That is, negative will cancel out each other and it will become small positive a. The left hand member of the above equation should be read as negative of a and not minus of a. A and 1 over a are the multiplicative inverses of each other, since by definition inverse of 1 over a is a, that is, inverse of a raised to power minus 1 is a. A raised to power minus 1 means 1 over a. That is the positive sign that was when it was above a in the denominator side. It became negative when it became on the opposite side, that is top numerator. And a cannot be equal to 0. Therefore, a raised to power minus 1, if a raised to power minus 1 will cancel out minus, it will become positive a, or 1 over a is equals to a. Now we have an example which states that prove that for any real number ab, first a is equals to a dot 0 is equals to 0 and ab is equals to 0, implying that a is equals to 0 and b is also equals to 0. Opposite of it stands or, and the when it is like a mountain, this symbol, it becomes and the 3 symbol dot, it actually means therefore. The mountain type symbol means and this last one means or. Now this example that prove that for any real numbers ab, a dot 0 is actually equals to 0. It is written that if you multiply any random variable a with 0, it will become 0, yes. And in order to prove that, you can just, solution is a dot 0 is equals to a into 1 plus 1 minus 1. Actually, it is written in the way that is property of additive inverse, right? Like 0 can be written as 1 plus into minus 1. Then it can also be further written 1 minus 1, and 1 will be multiplied with a, minus 1 will also be multiplied with a, and then it will become a minus a is equals to, and when we 0. Thus, but you have to keep a as well, because a dot multiplied by 0 will be equal to 0. And on the way down the example, the writer has actually explained that when a minus 1, a into 1 minus 1 at the second step, it was the definition of subtraction, then the distributive law, then property of multiplicative identity, and then the definition of subtraction, and then the property of additive inverse was applied. Then it was proved that a dot 0 is equals to 0. Given, then the second point is given that a b is equals to 0, then suppose a is not equal to 0. I believe these kind of questions are just for your understanding and for the properties that we have just studied. And these are very easy to prove, right? There is no difficulty at all. And it gives 1 over a dot 1 a, actually it gives 1 over a into bracket ab is equals to 1 over a dot 0. If we assume that ab is equals to 0, it is a multiplicative property of equality. And then you just have to multiply a with like that 1 over a dot a, and let's say if we separate b, and the right hand side is 1 over a dot 0, associative law of multiplication, and then 1 dot b, a will be on the left hand side, a will be cancelled out with 1 over a, and it will give you 1 dot b is equals to 0, b is equals to 0. Thus if ab is equals to 0 and a is not equals to 0, then b is also equals to 0, which has been proven. And similarly it may be shown that if ab is equals to 0 and b is not equals to 0, then a is equals to 0. Hence ab is equals to 0, it means either a is equals to 0 or b is equals to 0. It means that if you have a product of two numbers, product means that you are multiplying two numbers, then if their product is actually equals to 0, then that means that either a is equals to 0 or b is equals to 0.